Hello students, I welcome you all at SAFAL, Success Academy for Ace Learning. So today we are going to start a new chapter for class 10th, that is triangle. It's a very important topic, be it NTSC Olympiads or board exams. And the good part is this chapter is utilized in further upcoming chapters like coordinate geometry, circles, etc. So this chapter I have divided in a small modules. So starting with that, today we are looking at the first module, that is introduction part. So here we are going to recall some of the basics which you might be knowing already. But just before starting the chapter, I thought of recalling so that once the chapter starts, you all will be comfortable. So let's start. Now the first very basic question arises that what is a triangle? So triangle is defined as a closed figure bounded by three line segments. So you can see I have drawn a three-sided closed figure. So this is only what? Triangle. What are the three line segments? If let's say I am naming it A, B and C. So I can see that three line segments we have AB, BC and CA. The points where these line segments are meeting, that is A, B and C, we call it as what? Vertex. And at each vertex an angle is formed. Okay. So three sides we have. I can see here AB, BC and CA. Now three vertex we have. Three vertices we have A, B and C, and three angles we have. So all of you know how to denote angles also, right? So angle A, angle B and angle C. So a triangle has three sides, three vertices and three angles which I have listed. So this, of course, almost everyone will be knowing that. So moving ahead, then based on sides and angle, we have classification of triangles. Okay, so two classifications we have. The first one is based on sides and the second one is based on angles. So if you are looking based on sides, three classification we have under that. The first one we have is equilateral triangle. Now under what situation we are calling a triangle as equilateral? If all the three sides are what? Equal. Now three sides are there and all the three sides are equal. So we are going to call the triangle as what? Equilateral triangle. And also you might be knowing that each angle of equilateral triangle is what? 60 degree. Okay. So that is the first one. The second one we have is isosceles triangle. So here two sides will be same and the third will be what? Different. So that means a triangle in which two sides are equal and third is having a different length is called what? Isosceles triangle. Now here also one concept you might be knowing, that base angle of isosceles triangles are what? Equal. That means this angle and this angles are equal. When all the three sides having different length, then the triangle we call it as what? A scalene triangle. So here I can see that this is having different length, this is having different length and this one having a different length. So very simple, if all the three sides are equal, equilateral triangle. If two sides are equal, isosceles triangle. And if all the three sides having different length, then we call it as a scalene triangle. Also we can keep in mind that in equilateral triangle all the three angles are 60 degree. And in isosceles triangle, the two base angles are what? Equal. So this is the classification based on sides we have. Coming to based on angles, again we have three classification. The first one we have is a right angle triangle. That means a triangle in which one angle is what? 90 degree. So here you can see that in this triangle, one angle is 90 degree. So this is a right angle triangle. And of course you might be knowing whatever side is opposite to right angle triangle, that side we call it as what? Hypotenuse. So this I have taught even in trigonometry about right angle triangle. If all the three angles are less than 90 degree, that means all the angles are what? Acute. This angle, and this angle. All the three angles are what? Less than 90 degree. Then the triangle we call it as what? Acute angle triangle. If I am naming here, let's say A, B and C. So angle A is also less than 90 degree. Angle B is also what? Less than 90 degree. And angle C is also what? Less than 90 degree. And of course it has to be greater than what? 0 degree. Okay. So in that case the triangle we call it as acute angle triangle. Now if one of the angle of the triangle is greater than 90 degree, then the triangle is called what? Obtuse angle triangle. Now here if I am naming the vertices, let's say A, B and C. So here I can see that angle A is what? Greater than 90 degree. That means a triangle, we are calling it as obtuse angle triangle if one angle is greater than what? 90 degree. And of course it has to be less than 180 degree. So these are the classification based on sides and based on angles. Moving ahead, now some important theorems also we need to recall. So the first very basic theorem we have with us is the sum of three angles of a triangle is equal to 180 degree. Very important. If I have a triangle here, what you can see on the screen, if I take all the three angles together, if I am naming this as A, this as B and this as C, so we know that angle A plus angle B plus angle C added together makes up what? 180 degree. So we call it as angle sum property of triangle. We are utilizing this very frequently, so you need to keep in mind. The second theorem which you have already studied, if one side of a triangle is produced, so let's say I am producing what? BC. So the exterior angle so formed is equal to interior opposite angle. Now here I can see that I have, this is the exterior angle. If I am calling it as, let's say, Z degree. Now what are the interior opposite angle? I can see A and B. So let me call this as X degree and this is what? Y degree. So as per theorem 2, we have X degree plus Y degree is what? Z degree. That means the exterior angle is equal to sum of two interior opposite angles. So these two theorems are very basic and we will be utilizing in many cases. Now moving ahead, now we are looking at some spatial lines and spatial points in a triangle, and this topic is very important because many concepts from this topic we are utilizing in class 10th triangle chapter. So the first point we have is altitude of a triangle. Now what is altitude of a triangle? So an altitude of a triangle is a line segment drawn from any vertex perpendicular to the opposite side. Now what I am trying to tell is, if let's say this is the triangle, so how many vertices we have? 3 vertices, right? So from vertex we need to drop a perpendicular to the opposite side. So if I am naming, let's say A, let's say B and let's say C. So you can see from vertex A I have dropped a what? Perpendicular to opposite side, that is BC. So this is an altitude. Similarly from B I can drop perpendicular to what? AC, and similarly from C I can drop perpendicular to what? AB. So I can see that a triangle has how many altitudes? 3 altitudes. And all the 3 altitudes are meeting at a common point, and that common point we call it as what? Orthocenter of triangle. So altitude of a triangles are concurrent and the point of concurrence we call it as orthocenter, and generally we denote it by H. Okay, so very simple. If I need to draw altitude, I need to drop a perpendicular from vertex to the opposite side of the triangle. And the point of concurrence of altitude we call it as orthocenter, which is generally denoted by what? Capital letter H. Moving ahead, the next important point we have is median of a triangle. Now what is median? So median is a line segment joining a vertex of a triangle to the midpoint of its opposite side. Very important. In previous case we are dropping perpendicular from vertex to opposite side. In this case what we are doing? We are just connecting vertex to the midpoint of opposite side. So again I can name it A, B and C triangle. So from vertex A I need to connect it to midpoint of opposite side, that is BC. So here if I am writing, let's say D, so BD is same as what? DC. Okay, so this AD is median from vertex A. Similarly from vertex B also I can have median. So let's say this I am calling it as what? E. So here you can see that C should be same as what? A. Similarly from vertex C I can have third median. So again this is also what? Line joining vertex to the midpoint of opposite side. So let's say the midpoint is F. So AD, B and CF are medians. Now here you can note that the medians are concurrent. They are meeting at a common point, and this common point we call it as centroid, and usually we denote it by what? Capital letter G. So median is a line segment joining vertex to the midpoint of opposite side. A triangle has three medians and all three medians are concurrent, and the point of concurrence we call it as centroid. And the next important point we need to keep in mind related to this is centroid divides the median in the ratio 2:1. That means AG is 2 part, so GD is 1 part. Similarly, if BG is 2 part, so GE is 1 part. If CG is 2 part, so FG is what? 1 part. That means you'll find that AG by GD, BG by GE and CG by GF. So this ratio is what? 2:1. It's a very important property you need to keep in mind. So moving ahead to the next special line, perpendicular bisectors. Now perpendicular bisectors all of you know, right? So it's a line passing through midpoint of side of a triangle and perpendicular to the side. Very important. So if I'm taking a triangle, so it's a line passing through midpoint and perpendicular to the side of the triangle. So you can see that this is a line passing through what? Midpoint. These two lengths are equal, and also it is perpendicular to what? Sides. Similarly to the second side I can have. Okay, so here also these two lengths are what? Equal, perpendicular bisector. And similarly for third side also I can have a perpendicular bisector. Okay, so here also what? 90 degree. I can name it A, B and C. Okay, now here also you can notice that all the three perpendicular bisector are meeting at a common point. So the point of concurrence of the perpendicular bisector of the side of triangle, we call it a circumcenter. Usually we denote it by what? O. So the perpendicular bisectors of the sides of a triangle are concurrent, and the point of concurrence we call it a circumcenter. The next important point which you need to keep in mind that circumcenter is equidistant from all the three vertices. That means OA, OB, if I am writing this, let's say, so OA equals OB equals what? OC. Very, very important. And this equal distance we call it as what? Circumradius. Now taking O as center and R as radius, we can draw a circle which will pass through all the three vertices, and this circle we call it as what? Circumcircle of triangle ABC. So circumcircle of triangle ABC. So very important. That's what I have written in the bottom point. Circle with O as center and R as radius passes through all three vertices of the triangle and is called circumcircle of triangle. Okay. So circumcenter is point of concurrence of perpendicular bisectors of the sides of a triangle. It is equidistant from all the three vertices of triangle, and the distance we calling it as circumradius. So taking circumcenter as center and circumradius as radius, if we'll draw a circle, it will pass through all the three vertices, and that circle is called circumcircle of triangle ABC. So moving ahead further, the next special line we have is angle bisectors of a triangle. So of course the name is only what? Angle bisectors. So it's a line segment drawn from vertex and it bisects the vertex angle. Very important. So if I'm taking, let's say, this triangle, let me name it as A, B and C. So I need to draw a line segment from each vertex bisecting the angle. So here this angle is getting bisected. Here also this angle is getting bisected, and the third angle is also getting bisected. Okay. So you can notice that even the angle bisectors are meeting at a common point. So the angle bisectors of angle of a triangle are concurrent, and the point of concurrence we call it as what? Incenter. Usually we denote it by capital I. Okay. The next important point is this incenter is equidistant from all the three sides. Very important. So here we are looking at what? Perpendicular distance. Okay. So it is equidistant from all the three sides, and that equal distance we call it as what? In radius. Now taking I as center and this equal distance whatever r is there as radius, if you draw a circle, it will touch all the three sides. So that circle we call it as incircle of triangle ABC. And the formula for in radius you can keep in mind. It is given as area of triangle by semi-perimeter of triangle. So it's a very, very important note. Class 9th, some of you might have already studied. So angle bisectors are bisectors of angles of a triangle. They are concurrent at a point. That point we are calling it as incenter, generally denoted by capital I. Incenter is equidistant from all the three sides of a triangle, and that equal distance we are calling it as in radius. Taking I as center, a small r as radius, if we draw a circle, the yellow one what you can see on the screen, it will touch all the three sides, and this circle we call it as incircle of triangle ABC, and the radius formula for incircle is area of triangle divided by semi-perimeter. So after looking at a special line and special points, we have two very important points which we are utilizing in this chapter. The first one is triangle on the same base or equal bases and between the same parallel lines are equal in area. That means this is a triangle what you can see. If I draw another triangle, so you can see that the first one was, let's say, ABC, and the second one is what? ABD. So both the triangles have the common base, what? AB, and their vertex also lies on what? Same line. So I can see that this line is parallel to this line. So I can write that area of triangle ABC is same as what? Area of triangle ABD. This already you might have studied in class 9th. So two triangles on the same base and between the same parallel lines are equal in area. The next point, all of you might be knowing also, class 9th you have studied, that area of a triangle is given as 1 by 2 base into height. Also it is given using Heron's formula. You have studied in class 9th that area of triangle is S into S minus A into S minus B into S minus C under square root sign. So where A, B, C are sides of the triangle and S is semi-perimeter, which is given as A plus B plus C by